Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode from ID 3304. Find the kth character in string game 1. It's an easy problem and asked in Bloomberg. It is easy because the constraints are low. If the constraints becomes high, maybe let's say less than greater than equal to less than power 4, it will become medium. And here with the help of this problem we are going to revise these many topics: simulation, math, bit manipulation, recursion. Let's have a look on the problem statement. Here Alice and Bob are playing a game. Initially Alice has a starting string or word A. So they are starting with this string. And after that they have to perform some operation. You are given a positive integer k as well. Okay, starting string is this, they are saying, and they are also saying that the k integer is also given to us. Now Bob will ask Alice to perform the following operation forever. Keep on applying the operation. And the operation is generate a new string by changing each character in the word to its next character in the English alphabet and append it to the original string. Okay, so the operation is something for each character in this string. The string is currently having only one character. You use these characters as it is. And after that, just do one more iteration and increment every single character. A has a subsequent B. A plus one character is B. Next character is in English alphabetical order. So, from this word, after one operation it will become this. After one operation it will become AB, and A will become B, B will become C, A, B, B, C. So this is after second operation. Now what's ahead? Just an example that C will become CD because C as it is and C plus 1 increment performing the operation, and ZB. Z will become A. Z and B, first of all they have used it as it is, and after that Z have been converted to A and B is converted to C and written the value of kth character in the word. So after performing these operation, and these operation it's totally up to us. Like whenever we feel like applying operation, we can apply it, keep on applying. But it doesn't make any sense if we keep on applying operation because we are only concerned about the kth character. As far as kth character is in this range, we are good with the operations. So return the kth character from the word after enough operations have been applied on the word that we have at least k characters in it. And there is a note as well, the character Z will be converted to character A. It means it's a cyclic form. So A to Z and then Z to A again. So this is a problem statement. It's pretty straightforward that initially we have to start with A and we just have to return the kth character from the string. Kth character from the string, and let's say the k value of k is 1, first character, that we already know, that is A. If let's say k is second character, for that we have to increase the string, and string incremental will be done by applying the operation A as it is and increment every single character A and B. A as it is I have written here and then iterated over it, and every character incremented by 1. Character plus 1 typecasted to character. It will give the next character. What about k equal to 3? For k equal to 3, this is first character, I need a third character is not there. I need one more operation. A, B, and A will become B, B will become C. So this is the third character. Third character is B. And what about k equal to 4? K equal to 4 is C character. What is k equal to 5? Again we have to apply one operation. A, B, B, C. As it is, then A will become B, B will become C, C, and C will become D. So what is the fifth one? Fifth one is this. This is the sixth one. This is the seventh one, and this is the eighth one. Initially, when we have applied zero number of operations, the string was of 1 length, string was of 2 length after one operation, string was of 4 length after one more operation, string was of 8 length after one more operation. Every time it is getting double. If it is getting double and starting with 1, it's definitely a power of 2. So how do we approach this problem? How do we solve this problem? See, just apply this simulation. Do whatever is written in the problem statement. And they are saying they are starting with the string A. So let's say this is your current string. And this length of this string should be greater than equal to k, so that we will be able to get the answer. In this case, just keep on applying the operation. And how do we have to apply the operation? Just iterate over this string and increment every single character. So this is simulation. And for this, we know that strings are of two types: mutable and immutable. Immutable string, in some languages, let's say Java, it is string. And mutable, in Java, it is string builder. And why we are going to use mutable? Because we have to change the values so many times. So use the string builder object, initialize with A, and keep on applying the operations such that the value become greater than equal to k, and after that return the k minus 1th character. Right? Simple. Let me show you the code for this. So here, this is the code for simulation. I have used a Java snippet. Keep it as a like pseudocode. First of all, creating a mutable string object, and we have to keep on doing till the length crosses k. If it is less than k, we have to apply the operation. If it is greater than equal to k, we are good. Then we don't have to apply operation. If it is less than k, just apply the operation. An operation is something for every single character. I have to increment the value. So A will become B, B will become C, and Z will become A. Y will become C. So this is something I have to apply. Character will become character plus 1. But if C is Z, then it will become A and append it to itself. In the end, just return the k minus 1th character. This is how we can get the answer. So in this case, let's keep a very simple example again. Every time we are going to generate the same strings. So for k equal to 1, this is. Let's say k was 5. If k was 5, it means we want string greater than equal to 5. K is equal to 5. We want string greater than equal to 5. First of all, string is A. Then AB, it's still less than 5. A, B, B, C. Still less than 5. A, B, B, C, and an incremental of it. B, C, C, D. Now it is fine. Here the length is 8. 8 is greater than equal to 5. Yes, okay. We can stop here. And now I'm out of this loop. Return the k minus 1th character. 5 minus 1th character. 0, 1, 2, 3, 4. So this is going to be my answer. Okay. So I have to return B. Character is something I am returning here and taking an integer as input. So this much we have to do. So this is the simulation. And what is the time complexity here? In first iteration, it ran 2 times. In second iteration, it ran 4 times. In third iteration, it ran 8 times. So it's something like all the powers of 2, sum of all the powers of 2 till it reaches k. That will be approximately order of k time. And here in this case, this is not a good approach. Why? Because we are not concerned about the whole string. We are concerned about the character, whatever is going to the character at that position. It is going to run because the k value is very small. So as k value belongs to 1 to 500, this question will get this solution will get submitted, but this is not the optimized one. Not very efficient in terms of interviews. If you're giving it in the interviews, or maybe in some cases you are getting a very big range, or maybe get a second follow-up game 2. In that case it might fail. So there we have to do something optimized. Now let's have a look on the approach 2. In the approach 2, what we'll do is, instead of doing simulation, we will try to see what can be the exact character at that position. We will just try to find out the character. Initially the string is a, and it is of length 1 after applying 0 operation. After 1 operation it is ab, length is 2, we applied 1 operation, or in other terms the length is 2's power number of operations, or you can say number of steps we have done. After that a, b, c, the length is 4, 2's power 2, 1 operation, 2 operation. After apply one more operation, it will become a, b, b, c, and b, c, c, d. Length is 8, 2's power 3, and 1 more operation. And we have to keep on doing these things until this value, length, is less than equal to k. Right? We have to keep on doing the operations until this length is less than equal to k. Okay, let's first of all try to see what length we have to generate. How do we get to know? We can directly check this power of 2. We can directly check this power of 2. Which power of 2 is less than equal to k? While 2's power something less than equal to k. So if it is fine, then if it is less than equal to k, just do something. I have to do something, otherwise I am good. And what I have to do is, I have to do this thing, this step, 1 step, 2 step, 3 step. So I will keep on doing these things until this 2's power x is less than equal to k. If that is the case, we have to apply the steps. Now after this, we have got the idea that how many steps we have to perform actually. How many steps that I need to perform. Step plus plus. If the step is initially 0, step was 0 initially, then we have to apply 1 step. And in this case, it is something that will be based on k. So let's say I'm keeping k value as 7. 0, 1, 2, 3, 4, 5, 6, or maybe 7th. This is the 7th character. So 7 is less than equal to 2's power 3. So here in this case, I will be applying 3 steps. And after applying 3 steps, what I can do now? I have this state. I know how many steps are there, and I know what is the value of k. So here there are 2 possibilities. See this 7th character. Let's say this k value is falling in the first half. In this case, if it is falling in the first half, so whatever is the value of k, that will be equal to the kth character of previous step, from the previous step. Right? So what I'm saying, see we have to think recursively in this problem. Kth character we need to find. So if k is lying between the first half, it means from the previous step, whatever is the kth character, that is going to be our kth character. Otherwise, if it is lying in the second half, then whatever is the kth character from the first step plus 1 is my current answer. So let's say I write a function that at this step I want to know the kth character. First of all, if first half if it is lying in the first half, then what I can do is whatever the kth character from the step -1 previous step, that is going to be our character. Otherwise, if it is not in the first half, then the character from step -1, character from the previous step plus 1 is going to be my character. There are only these two possibilities. And what can be our base case? See, if step is 0, then definitely the character will be A. So directly return A. Whatever is the value of k, if we are reaching at the step 0, it is definitely A. At the step 0, this is the step 0, the character is A. At step 2, what is the character? See, the value, possible value of k can be 0, 1, or in the other terms 1 or 2, but I am keeping it 0 indexed. So if it is 0, it is lying in the first half. If it is lying in the first half, so it means 0 character from the previous step is my answer. If it is 1, it means 0, it means lying in the second half. So if it is lying in the second half, then what is the value? Here in this case, we need to take care of the length of the half portion. Here half portion is of length 1. So if the value of k lie between the second half, so k minus half of the length will be the overall mapping character from the previous step. Let me explain it to you again. First of all, let me just write the concrete code over this power of 2. In this case, if you are just directly going to find the power of 2, what we can do is we can use bit manipulation, as we also mentioned here. Bit manipulation, we are taking benefit of that. We need to keep track of the number of steps. Initially, I am at step 0, that is A to its power 0, while 1 left shift by step if this value is less than equal to k, or it is less than k, we have to perform the step. Why? Because for if my length, or maybe 2 की power something, 2 raised power x, if that is sufficient, if that is greater than equal to k, it means I have enough steps. Initially the step was 0. I was having 0 steps, that is A. Then I will check the power of 2. See, what is power of 0 power of 2? That is 1 in the binary. And what is 2 raised power 1? That is 1 0. What is 2 raised power 2? That is 1 0 0, and so on. The same left shift, this is the left shift operator, and this is the step, number of steps. Initially I am at 0 step, so 1 left shift by 0, that is 1. It means 2 raised power 0 is 1 in length, while 1 left shift step less than k, just do the step plus plus. So this portion is going to give me the steps, and now I am fine with the steps. After this, I need to solve a problem that at this step, what is the kth character? What is the kth character after performing these many steps? And this will be equal to, let's have a look on this bigger picture. If the value of k is equal to 7, it means it is lying in the right half. If it is lying in the right half, the corresponding character in the left half will be 7 minus what is the length of the half portion, that is 8 by 2, which is 4. 7 minus 4. 1, 2, 3, 4. This one, and this one I'm shifting k to this, and this is the same thing, getting the kth item from the previous step. Okay, this might be confusing, but okay, let me try to explain it again. At kth character at this step, we need to find A, B, B, C, B, C, C, D, and this is the 8th character at index 2, at index 7. So first of all, keep it 0 indexed. If I am keeping it 0 indexed, I have to find k minus 1th character. So just get rid of this 8. Okay, and now what I will do is, I know the steps. I know the step, and my current step is that length of the string would be 2 raised power 4. Not 2 raised power 3, it is 2 raised power 3 is the length. If 2 raised power 3 is the length, what is the half portion? Half length. And how do we get the half length? We can apply the same trick. One left shift by step, number of step. That is going to give me the whole length. But if I keep it step minus 1, it is going to give me the half length. So 2 raised power 3 is the length of this, and 2 raised power 3 divided by 2. 2 raised power 2 is the half of it. So this is the half it. If my value of k is greater than half, if it is greater than equal to half, in that case, what I have to do? See, this is the right portion. From the right portion, we have to shift it to the left. And the half portion is 4, and this is 4. So 0, 1, 2, 3, 4, 5, 6, 7. 7 should point to this actually. If it is one index, 7th character. Okay. So k is greater than equal to half. If k is greater than equal to half, it means that this character will be one more than the corresponding one from the left portion. Let's say this is C, so this is one more of this B. Solution: this item will be k minus half of the previous portion. Previous portion is same as the previous step, A, B, B, C. Why not we just directly jump to the previous step? So it is step minus 1. Step minus 1 and k minus half. So this character is just one more than the previous character. So whatever is the character I am going to get, plus 1. Otherwise, if k is less than half, in that case, whatever the step minus 1 kth value is going to be my character. The same function call you can make. So this is how we have to solve it. I will just show you the code. Now let's have a look on the code. See, first of all, we are only given this value k, and we have to return a character, and we just need to find out what step we have to go. It means that our length should be sufficient. This is at step 0, 2 raised power 0, 2 raised power 1, 2 raised power 2, 2 raised power 3. So 1 less than step less than k. Less than is sufficient, less than equal to is not required. The value is not sufficient. If the length is not sufficient, increment the step. After this, we have to call this function. See here, we have to see like our step is 0, then we'll go to step 1, go to step 2, go to step 3. At step 3, this loop will get over and we will come to this step. And now my function is that at this step, get character at step 3 what I need to know is, let's say I have to figure out the fifth character. What is the fifth character? This is the fifth character at index 4. So k minus 1. So this should be B. Let's try to find out using our code. This call I have made. In this call, what I am doing, this is the base case. If the step is 0, then all the characters are A. We don't have to check anything. Then what I will do, I will check the half of this length. This length is 8, and what is half? Half is 2's power 3 was 8. So 2's power 3 minus 2, which is 2's power 2, that is 4. So 4 is half of it. So what is 2's power 3? 1 left shift 3, or 1 left shift step. So this is 2's power 3, and 2's power 3 minus 1, that is 1 left shift step minus 1. So this is the same thing I am doing here. So I got the half. They are saying the condition I have used here is if index is less than half, if index is belonging to this portion. If index is belonging to this portion, then this is the same character from the previous step. So previous step, same character. It is a sub problem. First sub problem here. So if the k belongs to this portion, it is the same thing. If k is equal to 2, then this b I need to pick. I will pick it from the previous step. In this way, we are going in this direction towards the step 0, towards our base case. But what if k belongs to this portion? If k belongs to this portion, let's say here we are talking about the fifth character, that is 4. If k belongs to this portion, we have to shift it by half. Shift it by half, it means index minus half. So whatever the character, if we need B, so whatever is the character at k minus half, that is A. This is one less than my desired character. So whatever is the character, and this is one less from the desired character, so this is previous one. So previous plus 1. Plus 1 we have to do, and this is just to handle the edge case. So whatever is A is going to come here. And if A is same as the previous A, so why not I just decrement the step as well? In this case I will just move forward, because we have to reduce the problem statement, make it sub problem. In short, so what conclusion that we have got is that if k belongs to this portion, then this is the same A. If k belongs to this portion, this is the corresponding from the previous one plus 1. I hope you have understood this recursion function, and this is something, somehow we can optimize this code. And here, how many calls we are going to make? We are going to make calls. What is the height of this tower? Log of k, around log of k. So from linear to logarithmic, we have optimized it. And I hope you have understood the code and both the approaches. First of all, our brute force approach, the naive brute force approach, because of which this was mentioned as easy, and later on we have looked upon the recursion one. So simulation, math, bit manipulation, recursion is something we did. In case you get any doubt, just do let me know in the comment section or in the Discord community. Thank you guys, thanks for watching, bye bye.